is lambda? I want this to be very clear, otherwise you will not understand the next problem. What do you think is lambda?
Can we interpret lambda as a marginal rate of substitution?
No. It's not the marginal rate of substitution. It's actually marginal utility of x1 into x2, a marginal utility of x1 divided by the price of x1, which equals marginal utility of x2 divided by the price of x2, so on and so forth. So it's that common ratio, right? So what did I say lambda is? Yeah, we just defined lambda, no?
It is a marginal change in the objective function for 1 unit change in the constraint.
So if you relax the constraint by 1 unit, see ultimately the maximum utility that you can have in the problem depends upon what your income is. If I give you more income, you'll be able to consume more of x1 and x2. Right? So how much so the maximum utility that you can get depends upon what your income is. If I increase your income by 1 rupee, the maximum utility that you can get is also going to increase. The amount that it will increase by is given by lambda. The amount that it can increase by is, and I proved it to you in the last class, right? Because what did we say? Ultimately we said that if you think of the ratio, this common ratio we are going to call lambda. In equilibrium, these two ratios are the same, right? And what is MUX upon PX? 1 upon PX is the additional amount of sugar that you can get if I give you 1 more rupee, because the PX is the price of sugar. If it's 50 rupees a kilo, right? If I give you 1 more rupee, with 1 more rupee you can buy 1/50th of a kilo of additional sugar. MUX is the amount of utility you get by consuming 1 more unit of additional sugar. The total amount of additional sugar that you can get by 1 rupee is 1 upon Px multiplied by the increase per unit in the utility that you get gives you the total additional utility you can have if you spend at 1 rupee on sugar. 1 upon Px2 or 1 upon Py into Muy is the same answer if you spend at 1 rupee on y. And in equilibrium both have to be the same. Otherwise you will not be in equilibrium. You should be indifferent between spending that 1 rupee on both those things, right? That common ratio is called lambda. So obviously lambda is something. Lambda, what is lambda telling? If I give you 1 more additional rupee, how much more your utility can increase? If it's a utility maximizing problem. If it's any other maximization problem in general, then the utility function is the objective function and there is a constraint and it tells you how much the objective function can increase if I relax my constraint by 1 rupee. Right? So it's called or 1 unit. So it's called the shadow value of the constraint or the opportunity cost of the constraint or the marginal utility of money. So in this case the marginal utility of money and the opportunity cost of money is the same. What will be the opportunity cost of money? If you got 1 more rupee, how much additional utility you will be able to get? Right? So the opportunity cost of the constraint or the shadow value of the constraint and so on. Right? Is this clear? Now do you think pardon? Yeah. See, please look at this. Do you understand this equation very well? What is MUX? So what does marginality of X mean? Addition to total utility, right? Addition to total utility by consuming 1 more unit of X. Addition to total utility by consuming 1 more additional unit of X is MUX. What is 1 upon Px? The amount, what is, no, think of, what is 1 upon Px?
If you give 1 more unit of money, how much quantity?
So 1 upon Px, if Px is the price of X, then 1 upon Px is the amount of X that you can get by spending 1 more rupee on X. If something is 100 rupees a kilo, how much, suppose say some mithai is 100 rupees a kilo. How much mithai can you buy for 1 rupee? 1 upon 100, right? So 1 upon 100 is the additional mithai that you can get by 1 rupee. MUX is the total increase in the utility by consuming one more unit of mithai. So total utility increase by consuming one more unit of mithai into the number of additional units I can consume gives you the total increase in utility if I give you 1 more rupee and if you spend that on mithai. MUY by PY is the same thing for, say, chocolates, right? The additional utility you can get, additional increase in the total utility that the increase in the total utility that you can get if you spend that 1 more rupee on chocolates. In equilibrium, because the law of equimarginal utility, both have to be identical. That ratio is nothing but lambda. Because from the first equation it follows MUX minus lambda PX is equal to 0. Second equation follows MUY minus lambda PY is equal to 0. But MUX is derivative of the utility with respect to x1. So if I set up a Lagrangian like that, this is what it will be. So now tell me what is lambda, because it's absolutely important to understand what is lambda for the next part of the story. So what is lambda in a constraint optimization problem with equality? What is lambda? कितना देर तक बात किया ना तुम लोग ने?
The value of the constraint or what is the increase in the objective function when you relax?
What is the increase in the maximized value of the objective function when you relax the constraint by 1 unit? What is the increase in the value of the objective function if you relax the constraint by 1 unit is what is the Lagrange multiplier. Is everybody understanding this? Even the lazy ones? Yeah?
So, if we rearrange the lambda function and do MUX upon MUY and PX upon PY, then why is lambda not there? Why?
How can it be? So if you did that, lambda will vanish now.
Yeah.
See, it is this ratio.
Yeah.
It is MUX by PX which is lambda. It is because in equilibrium, MUX by PX has to be the same thing as MUY by PY, and that common ratio I refer to as lambda. That common,
Individually equal to lambda.
they have to be individually equal in equilibrium, right? If you are maximizing utility, then MUX by PX has to be equal to MUY by PY. So whatever they are, that common value, I will call that common value we call lambda. That common value we call lambda. Is it clear? It is not MUX by, it is not the marginal rate of substitution. Because if I try to get the marginal rate of substitution, lambda would simply not be there. Because I would have MUX will be lambda PX, MUY will be lambda PY. So the ratio lambda will cancel. There will be no lambda only. Right? Sure, I derive lambda from the marginal utility rate of equating the marginal rate of substitution to the ratio of prices, which gives me MUX by PX is equal to MUY by PY. This common ratio, which intuitively tells me that the additional utility that I will get by spending my 1 rupee on sugar is the same as the additional utility that I will get by spending my 1 rupee on apple if I am in equilibrium. You see the point why that has to be so in equilibrium? Can somebody tell me why in equilibrium MUX by PX has to be the same as MUY by PY? Yeah.
Because the consumer should arrive at that point wherein he doesn't have to think between spending his rupee on two particular goods. In the sense that the utility which he is going to get by spending on one good may be the same.
Why? Yeah. So if your consumer is equilibrium, he should not benefit from reallocating his expenditure. Otherwise you are not in equilibrium. You will be in equilibrium if you do not benefit from consuming more X and less Y or more Y and less X. Right? So this really means that in equilibrium, therefore, the consumer should be, it should not matter whether you spend your last rupee on X or last rupee on Y. They will give you the same utility. and its same addition increase in utility is lambda. Now tell me what is lambda. Because I still want you, all of you, to understand what is lambda, because I'm going to change the problem now and your understanding of what is lambda is going to become absolutely crucial. So what is lambda? What is the Lagrange multiplier? What do you mean by the Lagrange multiplier? Yeah, even Marty would have answered by this time. Yeah? Come on, take a shot, doesn't matter. I'm here to correct you if you're wrong. But make sure you understand this. If you don't, then you'll be hampered for life. So what is lambda? Yeah? You? Don't look away behind you. No, the guy behind you. Can you tell me what is lambda? You, yes. Your neighbor. Yeah. Say something. What is lambda? Can you say something? Just try and answer, there is no harm. No one is going to shoot you. I'm not carrying any guns on you. What is lambda? Can somebody help him? Can you tell me what you mean by lambda? Yeah? Come, say. Not, come on, tell me. Increase in the maximized value of the objective function if you relax your constraint by 1 unit. Is everybody understanding this? Sure? Right at the back? Pakka? Can I go ahead? Yeah. One more. I like it. Yeah. See, please understand the meaning of this. What is MUX upon PX? What is 1 upon PX? The additional amount of X that you can buy if you get one more rupee. What is MUX? The change in total utility if you consume one more unit of X. So suppose you can do that. No, because I am assuming concave functions. But the same logic will also work if you are minimizing functions. Not really, it will be a slightly different issue. Right, but we are not really, we will come to a theorem called duality at some point. Okay, but at this point, really let's concentrate on maximizing functions. Right? Sure? Because I can think of a problem where a firm is maximizing profits and that's actually a problem also as minimizing costs. Then the problem really becomes an identical problem when you look at a maximizing point of view or a minimizing point of view. That's called duality. We're going to come to those duality principles quickly. Right? Okay. So suppose MUX, the marginal utility of X is 3. What does it mean? If you consume one more unit of X, your total utility is going to increase by 3. That is MUX. Suppose PX is 2 rupees. PX is 2 rupees. So PX is 2 rupees a kilo. So what is 1 upon PX? Or say PX is, say, 2 rupees a unit. PX is 2 rupees a unit. Right? So what is 1 upon Px? That is how many units of X you can buy with 1 rupee. No? 1 upon Px is half. What is half? The amount of X you can buy with 1 rupee. Right? So with 1 rupee you can buy half a unit of X. Every additional unit of X leads to 3 units increase in utility. So if you spend 1 rupee on X, this says that your utility, total utility increased by 1.5 units. Is this clear? Total utility increased by 1.5 units. Right. Now if you are in equilibrium, the increase in utility by spending 1 more rupee on Y must be the same as the increase in utility by spending 1 more rupee on X. If the increase in utility by spending 1 more rupee on Y is more than the increase in utility by spending 1 more rupee on X, you will spend more on Y and less on X. In which case, you would not be in equilibrium, right? You will change your XY combination. So if you are in equilibrium, both the question must give you the same answer. Therefore, MUX by PX must be equal to MUY by PY, both should be equal to 1.5. That 1.5 is the value of lambda. It is called therefore the marginal utility of money, or in general the shadow value of the constraint. Has everybody understood it? Right? See, please remember, this is a very, very important, very crucial point for your entire career as economist. So make sure that you understand this idea, what is lambda, very, very, very clear. Right? Do you agree with this? Okay? Sure? Pakka? No clear, no confusion about what is lambda now? Right? Okay. Now, the next question that to ask you is, if you have an equality constraint, that is, you have to maximize utility with respect to x1 and x2, subject to a budget constraint. Will the lambda in equilibrium be positive, 0 or negative? Do you expect lambda to be positive, 0 or negative? If if your problem is an optimization problem with an equality constraint, right? So do you expect the lambda to be positive, negative or 0? Do you expect lambda to be positive, negative or 0? Yeah? What do you expect lambda to be? Positive, negative or 0? In equilibrium, what do you expect lambda to be? Positive, negative or 0? Think of again, what is lambda? If it is 0, what would it mean? The increase in the utility by giving you 1 more rupee is 0. Is that true? No. Right? Because, what are we really saying? If this is an indifference curve, this is an indifference curve, this is an indifference curve, if this is your budget line, if I give you 1 more rupee, what happens to the budget line? It goes up, right? So what will it become tangential to? A higher indifference curve. So does a higher indifference curve mean lower utility or higher utility, lower utility? Higher utility. So if I increase the budget line, I necessarily have a higher utility. If I am saying that the constraint is an equality constraint. If the constraint is an equality constraint, the tangency of the budget line and the indifference curve will be the equilibrium. So if I move the budget line outward, there will be no tangency. And therefore, lambda will always be positive. The additional utility by relaxing your budget line by 1 rupee will always be positive. Lambda will always be greater than 0. Right? Lambda will always be greater than 0. Now, you see the problem now is now we want to go to the more general. I am now saying that now I am going to say subject to I am now going to say that who told you to spend all your money? you go to the market to buy apples and oranges, nobody asks you to go and spend all your money, right? You can come home with some money, right? Okay, so the real problem is really maximize x1, x2 so that p1 x1 plus p2 x2 is less than or equal to m. This is an optimization problem with an inequality constraint. Okay, it's an optimization problem with an inequality constraint, right? So now if you think of, say this is x1, this is x2 and this is f of x2, the function. Let the values on the third axis. And suppose this gives me my budget line. Right? Suppose this is my, suppose I have something like this. Okay. This is the set of x1 and x2 which are feasible. Which are affordable. Right? Currently what we have assumed is I'll be in equilibrium only if I buy the most expensive x1 and x2 in the sense, okay, so that nothing slightly even above is affordable. So I'm buying only on the budget line. But it doesn't necessarily be true, right? I can go and buy a number of apples and oranges and get some money back home. Which means that I can actually have a utility function maximized in the interior of the budget set. It doesn't always have to be in the boundary of the budget set. It can be in the interior of the budget set as well. You see the kind of geometry that you did in the two, in college was required an equality constraint. Because you said that these are level curves, indifference curves. You had a set of feasible bundles. The higher the indifference curve you got, the more the utility you got. So you ruled out an equilibrium like this. You said the consumer can always push the indifference curve higher and still afford the consumption bundle. So you said the equilibrium will happen on the point at which the budget line and difference curve are tangential. But that did not necessarily always be true. Right? Because you have been saying that, x1, the more of x1 you consume, the more utility you get in x2. But it's entirely possible that I can actually maximize in the interior of the budget set. Right? Now there is a catch. The moment I can maximize in the interior of the budget set, okay, I don't have the condition p1 x1 plus p2 x2 is equal to m. I can as well have p1 x1 plus p2 x2 less than m. So the point then is that Lagrangian I don't then the problem is, then you see what will be the problem? If m is equal to p1 x1 plus p2 x2 is equal to 0, m is equal to p1 x1 plus p2 x2 is not necessarily true. Can you tell me what problem I will have? You cannot set it to 0. So what was the problem in the last problem which we saw x1 and x2? You can't solve for x1 and x2, no? So if you have an inequality constraint, previously क्या हुआ x1 is equal to lambda x2 something up you found out, no? And then m is equal to p1 x1 plus p2 x2, उधर वो 4x1 plus x2 कुछ था उसमें x1 x2 substitute करके you solve. Now, if you are allowing with inequality constraint, that equation is not going to be there. Because only going to be x1 plus 4x2 less than 16. Then we have to solve for x1 and x2. Right? Okay? So, there is an additional complication. Okay? There is an additional complication. हमारे पास वो last equation नहीं है to solve करने. You don't have the last equation. Right? Okay. So, how do you get an equation which will replace that? Can you think of an idea? That's why we are now talking about inequality constraints. you need to substitute that with some other equation. Now think of this. Think of lambda. Can lambda ever be negative? No. We rule out lambda being negative because if you give you one more rupee, you might not spend that rupee because you already bought what you wanted to buy, or spend that rupee and get some more. If you spend that rupee and get some more utility, lambda is positive. But if I give you that rupee and you return with that rupee, then relaxing your constraint has not increased your objective function, so lambda must be 0. So lambda can be either 0, in which case the equilibrium is happening inside the budget line, or lambda must be greater than 0 if the equilibrium is happening on the budget line. Right? अगर आपके पास 20 रुपया है and you repeatedly maximizing expenditure only 50 rupees, if I give you one more rupee, will your utility increase? No. You already got so suppose apples cost 3 rupees and oranges cost say 4 rupees, and you have bought your equilibrium utility maximizing allocation is 1 kilo orange and 1 kilo apples. So total expenditure is 12 rupees. You have bought 20 rupees. If I give you 1 more rupee, will you consume any more apples and oranges? No, because you consume your utility maximizing apples and oranges. So giving you 1 more rupee will not increase your utility. Right? In this case, what is the value of lambda? 0. Right? Opportunity cost of the constraint will be 0, or the shadow value of the constraint will be 0. On the other hand, if money is genuinely a constraint, if I give you 1 more rupee, you spend you buy more apples and oranges. Right? You buy more apples and oranges. Sure? In this case, the value of lambda will be greater than 0. So value of lambda can be 0 or greater than 0.